Remember, we said we wanted the nucleophile to be reactive. But we want it to be reactive with the organic substrate. We don't want it to be interacting with the solvent that we're using. So we have to think about whether our solvent is going to be protic or aprotic. Basically, solvents which are protic have hydrogens on polar covalent bonds. Solvents and molecules which are capable of hydrogen bonding to neighbouring molecules. But if we have a strong nucleophile with a negative charge on it, then we could unfortunately end up with the nucleophile interacting with the solvent if it's a protic solvent. And this is going to bog down the nucleophile, it's going to reduce its reactivity, and it's being clustered around by molecules of the solvent. So it decreases the activity of the nucleophile if we use a protic polar covalent solvent. It's being bogged down. It wants to be able to cleanly hit that organic substrate.
You said it decreases the activity.
So if it's trying to hammer into the organic, it doesn't help if it's being weighed down by attractions to solvent molecules. We do want the solvent to be polar, but we want it to be aprotic. A solvent that doesn't have polar covalent bonds to hydrogen. So some of the good choices would be things like acetonitrile. There's no hydrogen here, just a lone pair of electrons. No polar covalent bond to hydrogen. Dimethyl-formamide, sometimes known as DMF. Also makes for a good solvent. HMPA, hexamethyl phosphoramide, is in theory a good solvent, but it's actually also very carcinogenic. We really want to just skip that one. But in terms of the reactivity, it would be a good choice. So the solvent is always going to be polar for the SN2 substitution reaction. We just don't want it to be capable of hydrogen bonding. Because if it's capable of hydrogen bonding to another molecule, then it will hydrogen bond to the nucleophile. So the higher energy of the starting reagent, specifically the nucleophile, again gives us a lower energy of activation. Protic solvent, capable of hydrogen bonding, and therefore capable of bonding to the solvent with the nucleophile, will actually bring down the reactivity of our initial reagents and increase the energy of activation.